Hi everyone, today we're going to look at magnetic fields. So with me today I have a bar magnet and a button magnet, and we're going to look at the magnetic fields around and inside these magnets. So to show that, first let's start with the conventional drawing. Sorry. So this is the magnetic field around a magnet as we see in almost every physics textbook in this world. The next thing I have is something to demonstrate the magnetic field around and inside the magnet. So each of these holes here, these tiny holes, they are tiny iron sticks. And since iron is a ferromagnetic material, it's influenced by the magnetic field of the magnet. So when I place a magnet on it, it should, by theory, form the same pattern as the one which I drew on the piece of paper. The next apparatus which I have here is a little sophisticated. So this one is another demonstrator, and it shows me when you place a magnet here, it shows the magnetic field around one side of the magnet. And each of these little bubbles has a compass inside it. So in that compass, the red dot indicates the north pole of that compass, and the uncolored dot or the silver dot represents the south pole of that compass. So if I place it normally, it actually all the compasses point in the same direction that's there. I guess that's north pole then. So that's all for the apparatus, and let's get into the experiment. So the first apparatus, the first setup, we have here is the conventional magnet. I've kept the A4 sheet underneath it so that you can relate to and see how the fields actually align with each other. I'll shift this a little bit so that the bubble's center passes through the lines of force. So when I place this magnet here, you can see that these iron sticks kind of form those mini magnets which we can talk about, and therefore when they are attracted to this, they represent the field around the magnet. You can see that these lines are all coming on in line with the magnet, and they're all attracted to the magnet. So now what if I introduce another magnet to it? But actually before that, let's just have a look at the field underneath a magnet. So if I place a magnet here and I place this board on top of the magnet, you can see that the field inside the magnet is actually straight, and that shows how the magnetic field inside a magnet moves from the south pole to the north pole, because these are straight attraction field. So you have an outside field, and this forms a loop. So the magnetic lines of force go from the north pole outside like this. Just trace my finger and you'll see how the field lines actually go. So after that, let's see how does this field change when we introduce another magnet, a button magnet, to the same field. So now let's just see which is the north pole. So this is the north pole of this magnet. And if I place this here, you can see that these lines are straight. However, if I flip these, now this repels. And when this repels, the magnetic field lines of force actually go upward. So the central part, because there's a force of repulsion, and since magnetic field lines never intersect, they cannot cross each other. So the field lines in the center will actually nullify. So you can see that there is no direct field here. It's not a straight, it doesn't these are not parallel to the field lines, they're all going upward, and therefore the field lines are basically like this. If you trace my finger, they would actually go up like this for this, and up like this for this one. So let's try out the other apparatus. So the other one is the magnetic field demonstrator. So this one uses a compass, a bunch of compasses to show the magnetic field. So if I just pass my other magnet over these, you can see that they're all spinning everywhere because the magnetic field keeps changing. So let's place the magnet here. So as you can see that the north pole is here, and the south pole of this compass is attracted to the north pole of this. The south pole of this is attracted to the north pole of this. The south pole of this is attracted to the north pole of this. The south of this is attracted here, and they form this perfect little field around this. So if you trace these lines drawn on the board, you have the south here, the compass is actually aligned to the field lines drawn on the board. And since these field lines are drawn theoretically to an average magnet, you can see that the prediction is pretty true. And this way we can confirm what we see theoretically in our textbooks. And that's all for the experiment. You can also place a button magnet here and you see the same magnetic field. So the button magnet is basically a cylindrical bar magnet. So you can think of it like this. Just make this button magnet a little taller and that should do. That's it for the magnetic field demonstration. Give this video a thumbs up. Thanks for watching.